Question 1. The polynomial x cubed plus 2x squared minus 5x minus 6 has zeros, -1, -3 and alpha. What is the value of alpha? Consider the sum of the roots one at a time. That is, alpha plus beta plus gamma is equal to -b over a, where a is the leading coefficient, that is the coefficient of the x cubed term. So a is equal to 1, and b is the coefficient of the x squared term. So b is equal to 2. We know the value of beta and gamma. Beta is equal to -1 and gamma is equal to -3. So alpha plus -1 plus -3 is equal to -2 over 1. Now, -2 over 1 is equal to -2, and -1 plus -3 is equal to -4. So the equation simplifies to alpha minus 4 is equal to -2. Rearranging the equation to isolate alpha, we get alpha is equal to 2. Therefore, the correct answer is option B. Question 2. Consider the functions y equals f of x and y equals g of x and the regions shaded in the diagram below. Which of the following gives the total area of the shaded regions? We want the area enclosed between the two curves y equals f of x and y equals g of x. But the complication here is that the two curves intersect at multiple points. This means that in some intervals, one curve will be above the other, and in other intervals, it's reversed. This means the integral will need to be split up based on the intersection points. So that means that options A and B are incorrect. That leaves us options C and D. Now we can see that the integrals are split up based on the intersection points. So going back to the graph, we have an intersection point here, x equals -3, x equals -1, and at x equals 1. And the entire integral is from x equals -4 to x equals 4. Now we can also see that in the interval from x equals -4 to x equals -3, the function g of x is above f of x. So in order for the area to be positive, this will be the integral of g of x minus f of x between x equals -4 and x equals -3. If we consider option C, between x equals -4 and x equals -3, we have the integral of f of x minus g of x. And if we do that, f of x minus g of x will get a negative value, but we want a positive value. This immediately means option C is incorrect, which leaves us option D by default. But let's just consider the first integral. So the integral of f of x minus g of x from x equals -4 to x equals -3 will yield a negative result. But the negative in front of the integral will turn that into a positive. Therefore, the correct answer is option D. Question 3. Students from 4 different schools come together to form a choir. What is the minimum size of the choir to know that there must be at least 20 students in the choir from one of the schools? There are 4 different schools to choose choir members from. So let's choose 19 students from 4 different schools. So 4 schools times 19 students per school gives us 76 students. So the 77th student chosen has to come from one of the 4 different schools. So I've drawn 4 circles here to symbolize the 4 schools, and inside each of the circles there's 19 students. Now the question is asking for the minimum number of students to be chosen so that at least one of the circles has 20 students. So if we've chosen 76 students evenly distributed among the 4 circles, the 77th student has to go into one of these 4 circles, which will make one of those circles 20 students. So adding the 77th student will mean one of the groups will have 20 students. Therefore, the correct answer is option B. As a side note, By the pigeonhole principle, 77 students evenly distributed into 4 groups will mean that one of the groups will have 20 students and the other 3 groups will have 19 students. Question 4. What are the domain and range of the function y equals 2 times inverse cos of 2x plus 2 times inverse sine of 2x? Factorise out the coefficient of 2 from inverse cos 2x and inverse sine 2x. So y is equal to 2 times, open bracket, inverse cos 2x plus inverse sine 2x, close bracket. Now consider the domain. The value presented to either inverse cos or inverse sine has to be between -1 and 1. Now the value presented to inverse cos and inverse sine is 2x. This means 2x has to be greater than or equal to -1 and less than or equal to 1. We need to isolate the x. We do that by dividing all 3 terms of the inequality by 2. So -1 divided by 2 is -0.5 and 1 divided by 2 is 0.5 in decimal. So x is greater than or equal to -0.5 and less than or equal to 0.5. Hence, options C and D are incorrect. Now consider the range. It is known that inverse cos of u plus inverse sine of u is equal to pi over 2. And here is the reasoning. So consider this right angle triangle. Here's angle theta. This side here is 2x and the hypotenuse is 1. Now inverse cos of 2x over 1, so adjacent over hypotenuse, so in this case is 2x is equal to theta. That's this angle here. Inverse sine of 2x will be pi over 2 minus theta, which is this angle here. Recall that inverse sine of 2x, that's opposite over hypotenuse. So this becomes the opposite side relative to the angle here. This is the hypotenuse again. So inverse sine of 2x is equal to pi over 2 minus theta. And of course, inverse cos, inverse sine are complementary to each other. Hence, if we add these two equations together, inverse cos plus inverse sine is equal to theta plus pi over 2 minus theta. The thetas will cancel and we're left with pi over 2. So the range of y equals 2 times, open bracket, inverse cos of 2x plus inverse sine of 2x, close bracket, is equal to 2 times pi over 2, which equals pi. Therefore, the correct answer is option A. Question 5. Consider the function g of x equals 2 times inverse sine of 3x. Which transformations have been applied to f of x equals inverse sine of x to obtain g of x? Consider the domain of the function g of x equals 2 times inverse sine of 3x. From the point of view of the inverse sine function, it will only accept values greater than or equal to -1 and less than or equal to 1. This means 3x has to be a value that's greater than or equal to -1 and less than or equal to 1. Dividing all terms of this three-way inequality by 3 to isolate x, we get x is greater than or equal to -1 over 3 and less than or equal to 1 over 3. So what's occurred is a horizontal dilation by factor 1 over 3. Worded a different way, we can say it's a horizontal compression by factor 3. Let's consider the range. Now the range of inverse sine of 3x is greater than or equal to -pi over 2 and less than or equal to pi over 2. So recall this is in the vertical direction. Now we want 2 times inverse sine of 3x to match the function here. Multiplying all terms of this three-way inequality by 2 so we can achieve that. We get 2 times inverse sine of 3x has to be greater than or equal to -pi and less than or equal to pi. So what's occurred here is a vertical dilation by factor 2. Worded a different way, it's a vertical stretch by factor 2. Therefore, the correct answer is option C. Question 6. How many real value or values of x satisfy the equation the absolute value of b equals the absolute value of b times sine of 4x, where x is a value between 0 and 2 pi inclusive, and b is not 0. Rewriting the equation without the absolute value brackets, we get b times sine 4x is equal to plus or minus b. Dividing both sides of the equation by b, we get sine 4x is equal to plus or minus 1. That gives rise to two cases. Sine 4x equals positive 1 or sine 4x equals negative 1. Consider the curve y equals sine x, that's our base curve. We know that sine pi over 2 is equal to 1 and sine 3 pi over 2 is equal to negative 1. So in degrees, sine 90 degrees is equal to 1 and sine 270 degrees is equal to negative 1. But we're dealing with y equals sine 4x. This means it has a period pi over 2 rather than a period of 2 pi. So in the interval x greater than or equal to 0, less than or equal to 2 pi, the curve is repeated 4 times. Let's consider one repetition of the curve y equals sine 4x. And that's in the interval x greater than or equal to 0 and less than or equal to pi over 2. So in that interval, sine 4x equals 1 when x equals pi over 8, and sine 4x equals negative 1 when x equals 3 pi over 8. So from the graph, there are two solutions for sine 4x equals plus or minus 1 in the interval x greater than or equal to 0 and less than or equal to pi over 2. But the question wants the number of solutions in the interval x greater than or equal to 0 and less than or equal to 2 pi. Because the curve is repeated 4 times, we're going to have 4 times the number of solutions. So sine 4x equals plus or minus 1 will have 8 solutions in total in the interval x greater than or equal to 0 and less than or equal to 2 pi. Therefore, the correct answer is option D. Question 7. A driver's knowledge test contains 30 multiple choice questions, each with 4 options. An applicant must get at least 29 correct to pass. If an applicant correctly answers the first 25 questions and randomly guesses the last 5 questions, what is the probability that the applicant will pass the test? In the last 5 questions of this 30 question test, in other words, questions 26 to 30 inclusive, the applicant must get either 4 or 5 correct. In other words, no more than 1 mistake can be made in those last 5 questions in order to pass the entire test. Now we know that the first 25 questions were answered correctly, so we don't need to worry about those. We only need to concern ourselves with the last 5, and they're answered randomly. Now since there are 4 options, the probability of answering any one of questions 26 to 30 correctly is 1 over 4. The complement of 1 over 4 is 3 over 4, so the probability of making a mistake is 3 over 4. We have 2 possibilities to consider. Either the applicant gets all 5 correct, and the probability of that occurring is 1 over 4 to the power of 5, or the applicant makes 1 mistake in any one of these 5 questions. So the probability of getting exactly 4 correct is 1 over 4 to the power of 4 times 3 over 4 to the power of 1. So this is the probability of making a mistake. And this can occur 5 choose 1 different ways. If you consider this dash diagram, the x represents an incorrect or a mistake made. This x can be in any one of these 5 spaces. So adding these 2 probabilities together gives us the probability that the applicant will pass this test. So the probability of 5 correct plus the probability of 4 correct is equal to 1 over 64. Therefore, the correct answer is option C. Question 8. A local council is proposing to ban dog walking on the beach. It is known that the proportion of households that have a dog is 7 over 12. The local council wishes to poll N households about this proposal. Let P hat be the random variable representing the proportion of households polled that have a dog. What is the smallest sample size, N, for which the standard deviation of p hat is less than 0.06. The variance of the sample proportion p hat is given by the formula pq over n, where p is the population proportion, q is the complement of the population proportion, so in other words 1 minus p, and n is the sample size. In this case, the population proportion of people that own a dog is 7 over 12. So p is equal to 7 over 12, and q is the complement of 7 over 12. So 1 minus 7 over 12 is 5 over 12. Now we want to find the sample size n such that the standard deviation of the population proportion p hat is less than 0.06. Now the variance is the square of the standard deviation. So squaring 0.06, we get 0.0036. So we can reframe this question. We need to choose an n such that the variance of the sample proportion p hat is less than 0.0036. So we want to solve this inequality here. PQ over n less than sigma squared, which represents the variance of the sample proportion. Rearranging this inequality to isolate n, we want n greater than PQ over sigma squared. Now P is 7 over 12, Q is 5 over 12, and sigma squared, or the variance, is 0.0036. So we want n, an integer n that is, greater than 7 over 12 times 5 over 12 in brackets divided by 0.0036. And evaluating the right-hand side, we want an integer n greater than 67.515. And the smallest n that's greater than this value here is the integer 68. Therefore, the smallest sample size for the standard deviation to be less than 0.06 is 68. Therefore, the correct answer is option B. Now, just as a side note, as the sample size n increases or gets larger, the standard deviation, and by extension the variance of the sample proportion p hat, gets smaller. In fact, it approaches 0. Question 9. A bag contains n metal coins, n greater than or equal to 3, that are made from either silver or bronze. There are k silver coins in the bag and the rest are bronze. 2 coins are to be drawn at random from the bag, with the first coin drawn not being replaced before the second coin is drawn. Which of the following expressions will give the probability that the 2 coins drawn are made of the same metal? We can list the outcomes of this experiment using a 2-stage probability tree. Now we know there are n coins in the bag. Out of those n coins, we know that k must be silver. The rest are bronze. So if there are k silver coins in the bag, given that there are n coins in total, that means there must be n minus k bronze coins in the bag. Let's have a look at the probabilities in the first draw. So the probability of drawing a silver coin in the first draw must be k over n. And the probability of drawing a bronze coin, which is the complement of drawing a silver coin, must be n minus k over n. Now this is selection without replacement. We're not putting the coin back in the bag. So we're depleting the total number of coins in the bag by 1, which is why the probabilities in the second stage, the denominators are all n minus 1. So n minus 1, n minus 1, n minus 1, n minus 1. We just need to be mindful of the numerators. Let's have a look at drawing a second silver coin after drawing a silver coin in the first draw. So we've depleted the total number of coins by 1, so we have n minus 1 coins left in the bag. We've drawn a silver coin previously, which means there must be k minus 1 silver coins left in the bag. So the probability of drawing a second silver coin must be k minus 1 over n minus 1. There are still n minus k bronze coins in the bag, so the probability of drawing a bronze coin in the second draw after drawing a silver coin in the first draw must be n minus k over n minus 1. Let's have a look at drawing a silver coin in the second draw after drawing a bronze coin in the first draw. There are still K coins in the bag, but there are N-1 coins left. So the probability of drawing silver after drawing a bronze coin is K over N-1, and the probability of drawing a bronze coin after drawing a bronze coin in the first draw must be N minus K minus 1. So we've depleted the number of bronze coins by 1 already because we've already drawn a bronze coin here, and that's over N minus 1. Now the two outcomes that we're interested in are the two silver coins and the two bronze coins. So silver, silver, or bronze, bronze. So the probability of drawing the same two coins is equal to K over N times K minus 1 over N minus 1. So we're multiplying along the relevant branches in this tree diagram, plus N minus K over N times N minus K minus 1 over N minus 1. Now we have a common denominator here, which is N times N minus 1, which appears here. So combining the two fractions together, we get K times K minus 1 in brackets plus N minus K in brackets times N minus K minus 1 in brackets over N times N minus 1 in brackets. Therefore, the correct answer is option A. Question 10. For real numbers A and B, where A is not equal to 0 and B is not equal to 0, we can find numbers alpha, beta, gamma, delta, and R such that A cos x plus B sin x can be written in the following four forms: R sin x plus alpha, R sin x minus beta, R cos x plus gamma, R cos x minus delta, where R is greater than 0 and alpha, beta, gamma, and delta are greater than 0 and less than 2 pi. What is the value of alpha plus beta plus gamma plus delta? Since alpha, beta, gamma, and delta are all greater than 0, in other words, they're all positive, then the sum of alpha, beta, gamma, and delta must also be positive. Hence, option A is wrong. Now consider this equivalence. R sin x plus alpha is equivalent to R sin x minus beta, which is equivalent to R cos x plus gamma, which is equivalent to R cos x minus delta. All four of these statements represent A cos x plus B sin x. Also note that the period of all four of these functions is 2 pi. Now this will become important shortly. Consider the equivalence R sin x plus alpha is equivalent to R sin x minus beta. And I've noted that here. Now x minus beta is an angle. And we've noted previously that the period of R sin x minus beta is 2 pi. So adding 2 pi to the angle does not change the value of R sin x minus beta. So the equivalence stays the same. R sin x plus alpha is equivalent to R sin 2 pi plus x minus beta. We can divide both sides of this equivalence by R. So we get sine of x plus alpha is equivalent to sine 2 pi plus x minus beta. Taking the inverse sine of both sides, the two angles must be identical. So x plus alpha must be identical to 2 pi plus x minus beta. So x plus alpha is equivalent to 2 pi plus x minus beta. Now the x's cancel since we have an x here and an x there, which leaves us alpha is equal to 2 pi minus beta. Moving this minus beta over to the left-hand side, we get alpha plus beta is equal to 2 pi. Let's call this equation number 1. Now we can repeat this process with the next two trigonometric functions here. In other words, consider R cos x plus gamma is equivalent to R cos x minus delta. And basically what I've done is repeated the same thing, what I've done previously. So R cos x plus gamma is equivalent to R cos x minus delta. I can add 2 pi to this angle here, so the equivalence stays the same. Dividing both sides of this equivalence by R, we get cos of x plus gamma is equivalent to cos of 2 pi plus x minus delta. taking the inverse cos of both sides, we get x plus gamma is equivalent to 2 pi plus x minus delta. Now we can subtract x from both sides of this equivalence, and we form this equation. Gamma is equal to 2 pi minus delta. Moving this minus delta over to the left-hand side, we get gamma plus delta is equal to 2 pi. We'll call this equation number 2. Now, from equations 1 and 2, if we add both equations together, we get alpha plus beta plus gamma plus delta, and I've written that here on the left-hand side, is equal to 2 pi plus 2 pi. So that equals 4 pi. So alpha plus beta plus gamma plus delta is equal to 4 pi. Therefore, the correct answer is option D. Question 11, Part A. Consider the vectors. Vector A equals 3 times vector I plus 2 times vector j, and vector B equals negative I plus 4 times vector j. Part 1. Find 2 times vector A minus vector B. Vector A is defined as 3 times vector I plus 2 times vector j, and vector B is defined as negative vector I plus 4 times vector j. So 2 times vector A minus vector B can be expressed as twice 3i plus 2j minus negative I plus 4j. So that's 2 times 3i plus 2j in brackets minus negative I plus 4j in brackets. Now we can treat this as regular algebra. We expand the brackets and collect like terms. So expanding the brackets, we get 6i plus 4j plus I minus 4j. Now the plus 4j minus 4j add to 0, and 6i plus I is equal to 7i. So 2a minus b is equal to 7i. Part 2. Find the dot product of vectors a and b. The dot product of vectors a and b is found by multiplying separately the coefficients of vectors I and j and then adding those two products together. So in this case, the dot product of a and b is 3 times negative 1 plus 2 times 4. So 3 and negative 1 are the coefficients of the I vectors, and 2 and 4 are the coefficients of the j vectors. So 3 times negative 1 plus 2 times 4 is equal to 5. Question 11, Part B. Solve x squared minus 8x minus 9 less than or equal to 0. Since the inequality involves a quadratic expression, we can solve this graphically by considering the graph of y equals x squared minus 8x minus 9, which is a concave up parabola. Now to find where the parabola intercepts the x-axis, we can write the quadratic expression in factor form. And by inspection, x squared minus 8x minus 9 can be written as x plus 1 in brackets times x minus 9 in brackets, and it's less than or equal to 0. So by the null factor theorem, the concave up parabola y equals x squared minus 8x minus 9 crosses the x-axis at x equals negative 1 and at x equals 9. And the solution is the interval where the parabola y equals x squared minus 8x minus 9 is on or below the x-axis. Therefore, x is greater than or equal to negative 1 and less than or equal to 9. Question 11, Part C. Using the substitution u equals x minus 1, find the integral of x times the square root of x minus 1 dx. Starting with the substitution u equals x minus 1, differentiate u with respect to x. We get du dx is equal to 1. Moving the differential dx over to the other side, we get du is equal to dx. And that's the relationship between the two differentials. Later on, we will need to replace the dx with du. And knowing that du is equal to dx, all we have to do is just remove the dx and replace it with du. We also need to replace the x minus 1 in the integrand with u. We also need to replace the x here as well. So making x the subject in the original substitution, we have x is equal to u plus 1. So the integral of x times x minus 1 in brackets to the power of half, notice that I've written the surd in index form. We can replace it with an integrand in terms of u. So x is replaced with u plus 1 and x minus 1 is replaced with u. And the differential dx is replaced with du. So the integral becomes the integral of u plus 1 in brackets times u to the power of half du. Expanding the brackets, we get the integral of u to the power of 3 over 2 plus u to the power of 1 over 2 du. Performing the integration, we get 2 over 5 times u to the power of 5 over 2 plus 2 over 3 times u to the power of 3 over 2 plus the constant of integration c. But the solution needs to be in terms of x, not in terms of u. And we know that u is equal to x minus 1. So replacing the u here and here with x minus 1, we get 2 over 5 times x minus 1 in brackets to the power of 5 over 2 plus 2 over 3 times x minus 1 in brackets to the power of 3 over 2 plus the constant of integration c. And expressing the solution in surd form, we can write it as 2 times the square root of x minus 1 in brackets to the power of 5 over 5 plus 2 times the square root of x minus 1 in brackets to the power of 3 over 3 plus c. Question 11, Part D. Solve the differential equation dy over dx equals xy, given y is greater than 0. Express your answer in the form y equals e to the power of f of x. Use separation of variables to rework the differential equation so that like terms are grouped together. The differential dy needs to be grouped with the variable y, and the differential dx needs to be grouped with the variable x. We can do that by moving the differential dx over to the right-hand side by multiplication, since it's currently dividing dy, and we can move the variable y from the right-hand side over to the left-hand side by division because y is currently multiplying the x. So the differential equation becomes dy over y is equal to x times dx. Integrating both sides of this equation, we get the integral of 1 over y dy is equal to the integral of x dx. Now the integral of 1 over y dy is ln of y, and the integral of x dx is x squared over 2, and we need to add the constant of integration c. Now given that y is positive, we only have to consider one case. If we're not given the fact that y is positive, we'll have to consider two separate cases, ln of y and ln of negative y. Raising both sides of the equation to the base e, so we can make y the subject, we get y is equal to e to the power of x squared over 2 plus c. Question 11, Part E. Differentiate the function f of x equals arc sine of x to the power of 5. Recall that the derivative of arc sine of g of x or inverse sine of g of x using the chain rule, because we have a function of a function or a composite function, is given by 1 over the square root of 1 minus g of x in brackets squared times the derivative of g of x, which is g dash of x. And that can be written as g dash of x over the square root of 1 minus g of x in brackets squared. Hence, the derivative of arc sine of x to the power of 5 is equal to g dash of x. So differentiating x to the power of 5, we get 5x to the power of 4 over the square root of 1 minus x to the power of 5 squared using the power to or power index law, that's x to the power of 10. So we get 5x to the power of 4 over the square root of 1 minus x to the power of 10. Question 11, Part F. The volume of a sphere of radius r centimeters is given by V equals 4 over 3 times pi r cubed, and the volume of the sphere is increasing at a rate of 10 cubic centimeters per second. Show that the rate of increase of the radius is given by dr dt equals 5 over 2 pi r squared centimeters per second. Using the chain rule, we can come up with an equation that links together the relevant related rates of change. So dv dt, so that's the rate of change of volume with respect to time, is equal to dv dr, the rate of change of volume with respect to the radius, multiplied by dr dt. So that's the rate of change of radius with respect to time. Now the question is asking us to show that dr dt is 5 over 2 pi r squared. So we can rearrange this equation here to make dr dt the subject. And we can do that by taking dv dt and dividing it by dv dr. So dr dt is equal to dv dt divided by dv dr. We'll call this equation number 1. Now we're given an equation for V, the volume. V is equal to 4 over 3 times pi r cubed, but we want dv dr. So that's this rate of change here. So differentiating V with respect to R, we get dv dr is equal to 4 pi r squared. Now it's given in the question that dv dt is equal to 10. So that's the rate of change of volume with respect to time. So from equation number 1, we have dv dt, which is 10. We have an expression for dv dr, which is 4 pi r squared. We have dr dt is equal to 10 divided by 4 pi r squared. Written in fraction form, that's 10 over 4 pi r squared. And we can simplify 10 over 4, which is 5 over 2. So we have dr dt is equal to 5 over 2 pi r squared. Therefore, dr dt equals 5 over 2 pi r squared centimeters per second as required. Question 11, Part G. The region R is bounded by the curves y equals sine x, y equals x, and the line x equals pi over 2 as shown in the diagram. Find the area of the region R. Since the line y equals x is on or above the curve y equals sine x, the area R is given by the integral of x minus sine x dx from x equals 0 to x equals pi over 2. Now the line y equals x forms a right angled triangle, in fact an isosceles right angled triangle with the x-axis. So we could just use the area of a triangle formula, half times base times height, to find the area bounded by the line y equals x and the x-axis. So we get half times pi over 2, which is the base of this right angle triangle, times the height, pi over 2, since its gradient is 1. And that gives us pi squared over 8. But then we need to subtract from that negative cos x from x equals 0 to x equals pi over 2. So negative cos x is found by integrating sine x with respect to x. Now we have a minus and a negative, which becomes a positive here. So the area R is given by half times pi over 2 times pi over 2 minus negative cos x from x equals 0 to x equals pi over 2, which gives us pi squared over 8 plus cos pi over 2 minus cos 0. We get this expression by applying the limits of integration here. Now cos pi over 2 is 0 and cos of 0 is 1. So the area R is given by pi squared over 8 plus 0 minus 1. And of course the plus 0, we don't need to state that. So we get pi squared over 8 minus 1 for the area of R. So therefore the area of R is pi squared over 8 minus 1 square units. Question 12, Part A. The vectors a squared 2 and a plus 5, a minus 4 are perpendicular. Find the possible values of a. Two vectors that are perpendicular or 90 degrees to one another have a dot product of 0. Hence a squared times a plus 5 in brackets plus 2 times a minus 4 in brackets equals 0. Expanding the brackets on the left-hand side of this equation, we get a cubed plus 5a squared plus 2a minus 8 equals 0. Now we formed a cubic polynomial equation and we want to find the values of a such that the left-hand side of this equation is equal to 0. Now we can use polynomial techniques to find possible zeros. One way we can do that is to consider the factors of the constant term 8. And the factors of 8 are 1, 2, 4, 8, negative 1, negative 2, negative 4, and negative 8. We can use the factor theorem to check each of these factors by substituting those factors for a in the left-hand side of this equation and then evaluating the left-hand side of this equation, checking to see that it's equal to 0. And if it is, then we've found a value of a that solves this equation. I didn't show the substitution in this solution, but it's easy enough to do. So checking these factors of 8 one by one, I found that the left-hand side is 0 for a equals negative 4, a equals negative 2, and for a equals 1. Therefore, the possible values of a are negative 4, negative 2, and 1. As a side note, a cubic polynomial equation, that is, a polynomial equation of degree 3, similar to the equation that we just solved, will have no more than 3 real solutions by the fundamental theorem of algebra. And it just so happens that we found 3 real values of a, that is negative 4, negative 2, and 1, that satisfy this equation, which is why we can end the solution at that point. If we only found one possible value of a by considering factors of the constant term, we may then need to use polynomial division to try and find other possible values. Question 12, Part B. The region R is bounded by the function y equals x to the power of 3, the x-axis, and the lines x equals 1 and x equals 2. What is the volume of the solid of revolution obtained when the region R is rotated about the x-axis? It helps to sketch the curve y equals x to the power of 3 in order to visualize the volume that is to be generated. So the curve y equals x to the power of 3 is being rotated about the x-axis from x equals 1 to x equals 2, and we want to find the volume that is formed. And the way we do that is to consider the large volume, that is the volume formed from x equals 0 to x equals 2, and we subtract from that the smaller volume, that is the volume formed from x equals 0 to x equals 1, and that gives us the remaining volume, which is what we want. So in effect, we're finding a composite volume. And the expression is formed like this. So the volume is pi times the integral of x cubed in brackets squared dx from x equals 0 to x equals 2. That's the large volume from x equals 0 to x equals 2. And we're subtracting from that the smaller volume. That's this volume here. That's pi times the integral of x cubed in brackets squared dx from x equals 0 to x equals 1. Now, x cubed in brackets to the power of 2 is x to the power of 6. So that's the power of a power index law. And it's the same thing here as well. And integrating x to the power of 6, we get x to the power of 7 over 7. So the volume is pi times x to the power of 7 over 7 from x equals 0 to x equals 2. So that's the large volume, minus the small volume, pi times x to the power of 7 over 7 from x equals 0 to x equals 1. Applying the limits of integration, we get pi over 7. Now that 7 comes from this 7 here. I'll just factorize that out. Pi over 7 times open bracket 2 to the power of 7 minus 0 close bracket minus pi over 7 times open bracket 1 to the power of 7 minus 0 close bracket. And we can factorize pi over 7 from both of these terms here. And we get pi over 7 times open bracket 2 to the power of 7 minus 1. Now 2 to the power of 7 is 128. So 128 minus 1 is 127. So we get 127 pi over 7 cubic units. Question 12, Part C. A charity employs a worker to collect donations. There is a 0.31 chance that when the charity worker talks to someone, a donation is made to the charity. Each day the charity worker must talk to exactly 100 people. Use the standard normal distribution and the information on page 13 to approximate the probability that, on a particular day, at least 35% of the people talked to made a donation. It's given that n is 100, so we can consider that n is a large value. So we can approximate the probability that at least 35% of people spoken to will donate to this charity using the standard normal distribution. Now we'll set mu as 0.31, so that is the population proportion that's given. We need to find the standard deviation, and we use the formula, the square root of pq over n. So p is 0.31. Q is 1 minus P, so 1 minus 0.31 is 0.69, and N is 100, so that's our sample size. And that approximates to 0.04624932432, so I've just copied what was on the calculator screen. Next, we need to find the Z-score corresponding to 0.35, which is the decimal equivalent of 35% here. And that's given by the Z-score formula. So Z is equal to 0.35 minus mu, so that's 0.31 in brackets, divided by the standard deviation, which we found up here. So that's 0.0462 and so on. And that equals 0.864877. And that's equal to 0.86, correct to 2 decimal places. So next, we need to use the table on page 13. So this is the table here. And we need to locate Z equals 0.86. But just before we do that, just look at the diagram here carefully. The values of Z, correspond to the area under the curve to the left of z, but we want the area to the right of z. So we need to keep that in mind later on. But let's locate z equals 0.86. So there's z equals 0.8. And if we go to the 0.06 column, we get this value here, 0.8051. So using the table, the probability that z is greater than 0.86 is equal to 1 minus the probability that z is less than 0.86. So we're using the complement here. And that's equal to 1 minus 0.8051. And that was the value that we just found in the table. And that equals 0.1949. Therefore, there is around a 19.49% chance that at least 35 people out of 100 will donate. Question 12, Part D. Use mathematical induction to prove that 2 to the power of 3n plus 13 is divisible by 7 for all integers n greater than or equal to 1. The first step is to show that 2 to the power of 3n plus 13 is divisible by 7 for some integer value of n greater than or equal to 1. And the smallest value of n that we can check is n equals 1. So substituting 1 for n into the statement, we get 2 to the power of 3 times 1 plus 13, which evaluates to 21, and that is divisible by 7. Hence the statement is true for n equals 1. Next, assume that 2 to the power of 3n plus 13 is divisible by 7 for some integer value of n equal to k. In other words, we could write 2 to the power of 3k plus 13 equals 7a, where a is an integer. Next, we need to show that 2 to the power of 3n plus 13 is divisible by 7 for an integer n equals k plus 1. So it's just the next integer along from k. In other words, we need to show that 2 to the power of 3 times k plus 1 in brackets plus 13 equals 7b, where b is an integer. So from the left-hand side, expanding the brackets here in the index, we get 2 to the power of 3k plus 3 plus 13 is equal to 2 to the power of 3k times 2 to the power of 3. So all I've done is I've just broken up this term here and converted it into a product of two terms with the same base. Then we add 13 to that. Now 2 to the power of 3 is equal to 8. So 2 to the power of 3k plus 3 plus 13 can be written as 8 times 2 to the power of 3k plus 13. Now going back to our assumption, and this is our assumption here, I'm going to rearrange this assumption to make 2 to the power of 3k the subject. And what I want to do is express this statement here in terms of a. Now from the assumption, 2 to the power of 3k is equal to 7a minus 13. Hence, 8 times 2 to the power of 3k plus 13 is equal to 8 times 7a minus 13 in brackets plus 13. Expanding the brackets, we get 56a minus 104 plus 13, which simplifies to 56a minus 91. And we can factorise out 7 from both terms, so that equals 7 times 8a minus 13 in brackets. And that is divisible by 7, since 8a minus 13 is an integer. Therefore, by mathematical induction, 2 to the power of 3n plus 13 is divisible by 7 for all integers n greater than or equal to 1. Question 12, Part E. The diagram shows the graph of y equals 1 over the absolute value of x minus 5. For what values of x is x over 6 greater than or equal to 1 over the absolute value of x minus 5? Find critical points by solving as an equation x over 6 equals 1 over the absolute value of x minus 5. What we're finding are the points where the line x over 6 meets the hyperbola 1 over the absolute value of x minus 5. A couple of points to note here. Firstly, x cannot equal 5, since the denominator of the right-hand side cannot equal 0. Also, the right-hand side is positive because the absolute value of x minus 5 is greater than or equal to 0. So the entire fraction must be positive. And we know that x minus 5 cannot equal 0, or else we'll have division by 0 occurring. So if the right-hand side is positive, that means the left-hand side must also be positive. That means x itself has to be greater than 0. This will become important a little bit later on. Now, because we're solving an equation involving an absolute value, this gives rise to two cases. We have a positive case and a negative case. Let's consider the positive case, case 1. X over 6 equals 1 over x minus 5. By cross multiplication, we can form the equation x squared minus 5x equals 6. Moving the 6 over from the right-hand side over to the left-hand side will form a monic quadratic equation x squared minus 5x minus 6 equals 0. And that factorizes to x plus 1 in brackets times x minus 6 in brackets equals 0. And by the null factor theorem, we have x equals negative 1 or x equals 6. But we stated earlier that x has to be positive. So we'll discard x equals negative 1. Let's consider the negative case, case 2. So we have x over 6 equals negative 1 over x minus 5. So we'll repeat the same thing that we did in case 1. By cross multiplication, we can form the equation x squared minus 5x equals negative 6. Moving the negative 6 over to the left-hand side becomes positive 6. So we'll form the monic quadratic equation x squared minus 5x plus 6 equals 0. And that factorizes to x minus 2 in brackets times x minus 3 in brackets, and that equals 0. And by the null factor theorem, we get x equals 2 or x equals 3. Hence, the four critical points are x equals 2, 3, 5, and 6. Now that we have found the critical points, we need to test the inequality around the critical points either algebraically or graphically. I'm going to test the inequality graphically by sketching the line y equals x over 6 on the existing graph that's given in the question. Let's have a look. So this is the graph that's supplied in the question. This is the graph of y equals 1 over the absolute value of x minus 5. We can see that it's a type of hyperbola. It has a vertical asymptote at x equals 5, which happens to correspond to one of the critical points that we found earlier. Now the line y equals x over 6 is a line with a positive gradient passing through the origin, and it intersects with the hyperbola at 3 points, which correspond to the 3 other critical points that we found at x equals 2, x equals 3, and at x equals 6. And we're interested in the intervals of x where the line is on or above the hyperbola. And that occurs between x equals 2 and x equals 3, or on or after x equals 6. So from the graph, x over 6 is greater than or equal to 1 over the absolute value of x minus 5 in the interval x greater than or equal to 2 and less than or equal to 3, or x greater than or equal to 6. Question 13, Part A. In an experiment, the population of insects, P of t, was modelled by the logistic differential equation, dp dt equals p times 2000 minus p in brackets, where t is the time in days after the beginning of the experiment. The diagram shows a direction field for this differential equation, with the point S representing the initial population. Part 1. Explain why the graph of the solution that passes through the point S cannot also pass through the point T. Let's examine the behavior of the tangent lines as we move from point S to point T on the direction field. Let's start at point S. If we move horizontally along, we can see that the gradient of the tangent lines are identical, and it's positive. So the rate of change of the population with respect to time is increasing, so the population is going up. Now let's see what happens vertically as we move from point S to point T, but just examining the gradient of the tangent lines in the vertical direction, we can see they're becoming less and less positive. In other words, the gradient's decreasing until we reach this point here. When the population is 2,000, the gradient of the tangent lines is 0. In other words, the rate of change of the population with respect to time is 0, which means the population is not rising beyond 2,000, which means that we cannot reach point T. The maximum we could reach is 2,000 over time. Let's have a look at the explanation. So I've supplied a little bit of extra detail here, but I'll go through it. So by inspection of the direction field, as the population approaches 2,000 from point S, the gradient of the tangent lines decrease from a positive value and approaches 0 as the population approaches 2,000. Now at population 2,000, the gradient of the tangent lines is 0, indicating a population rate of change of 0. In other words, the population cannot rise beyond 2,000 and reach point T. Part 2. On the diagram provided on page 1 of the question 13 writing booklet, clearly sketch the graph of the solution that passes through the point S. When sketching the solution through point S, the curve should follow the general direction of nearby tangent lines. Here is my solution. I've started slightly to the left of point S. So going from left to right, we can see that the curve is increasing all the way through until we reach the horizontal asymptote where the population is 2,000, at which point the rate of change of population is 0, indicated by the gradient of the tangent lines being 0 there. Examining the behavior of this curve from left to right, we can see that the curve is increasing at an increasing rate up until around this point here. This represents a point of inflection. So this is where the rate of change of population is at its greatest. From this point onwards, we can see that the curve is increasing but at a decreasing rate until it approaches a rate of change of 0. Part 3. Find the predicted value of the population, P of t, at which the rate of growth of the population is largest. From part 2, we've observed that there's an inflection point around here which represents the maximum rate of change of population with respect to time. So when examining the behavior of the curve is increasing at an increasing rate until we get to around this point here, and then from this point here, it's increasing at a decreasing rate. So it's estimated that the population is increasing at its greatest rate when the population is 1,000. But let's work this out algebraically. So we want to solve the second derivative, d squared p dt squared equals 0. So we're going to find this inflection point. Now we know that dp dt is given as p times 2000 minus p in brackets. Expanding the brackets, we get 2000p minus p squared. And that's our first derivative, which we'll need to differentiate again to get the second derivative. So differentiating dp dt to get d squared p dt squared, we get 2000 minus 2p. So solving d squared p dt squared equals 0, so 2000 minus 2p equals 0, we get p is equal to 1000. But we need to test whether p equals 1000 represents an inflection point by examining the sign of d squared p dt squared around p equals 1000. Now when p is equal to 500, using this equation here, we get d squared p dt squared's 1000, so that's positive. When p is equal to 1000, we get second derivative is 0, and when p is equal to 1500, we get second derivative of negative 1000. So positive, 0, negative. We have a sign change in the second derivative, and that's around p equals 1000. Hence, p equals 1000 is an inflection point where the population rate of change is greatest. And this was observed on the direction field. Therefore, the population rate of growth is maximum when P of t is equal to 1000. Question 13, Part B, Part 1. Show that cos to the power of 4x plus sine to the power of 4x equals 1 plus cos squared 2x over 2. One way to do this is to consider the expansion of sine squared x plus cos squared x in brackets to the power of 2. By expanding this expression here, we'll end up with terms involving cos to the power of 4x and sine to the power of 4x. Also, sine squared x plus cos squared x is a Pythagorean trigonometric identity that's equal to 1, and that'll come in handy later on. So expanding sine squared x plus cos squared x in brackets to the power of 2 using perfect square expansion, we get sine to the power of 4x plus 2 sine squared x cos squared x plus cos to the power of 4x. As stated earlier, sine squared x plus cos squared x is equal to 1, and 1 squared is equal to 1. Also, sine squared x cos squared x can be expressed as sine x cos x in brackets to the power of 2. So the equation becomes 1 equals sine to the power of 4x plus 2 times sine x cos x in brackets to the power of 2 plus cos to the power of 4x. Rearranging this equation to isolate sine to the power of 4x plus cos to the power of 4x, the equation becomes cos to the power of 4x plus sine to the power of 4x is equal to 1 minus 2 times sine x cos x in brackets to the power of 2. Let's focus on what's in brackets here. Sine x cos x. Recall the double angle identity. Sine 2x is equal to 2 sine x cos x. If we divide both sides of this identity by 2, we get half sine 2x is equal to sine x cos x. Let's go back to this expression here inside the brackets. We're going to replace the sine x cos x with half sine 2x. So the equation becomes cos to the power of 4x plus sine to the power of 4x is equal to 1 minus 2 times, open bracket, half sine 2x, close bracket, to the power of 2. Expanding the brackets, we get 1 minus 2 times 1 over 4 times sine squared 2x. Now using another Pythagorean identity, this time on sine squared 2x, we can express sine squared 2x as 1 minus cos squared 2x. So the right hand side of the equation becomes 1 minus half, open bracket, 1 minus cos squared 2x. Now this half here comes from 2 times 1 over 4, and that's where this comes from. So expanding the brackets, we get 1 minus half plus half times cos squared 2x. Now collecting like terms, 1 minus half, or 1 over 2, is equal to half, plus half cos squared 2x, and written with a common denominator of 2, so we can combine both of these terms together into a single fraction, we get 1 plus cos squared 2x over 2. Therefore, cos to the power of 4x plus sine to the power of 4x equals 1 plus cos squared 2x over 2 as required. Part 2. Hence or otherwise, evaluate the integral of cos to the power of 4x plus sine to the power of 4x dx from x equals 0 to x equals pi over 4. Let I represent the integral from x equals 0 to x equals pi over 4 of cos to the power of 4x plus sine to the power of 4x dx. That integral can be written as the integral from x equals 0 to x equals pi over 4 of 1 plus cos squared 2x over 2 dx using the result from part 1. If you recall from part 1, we were asked to prove that cos to the power of 4x plus sine to the power of 4x is equal to 1 plus cos squared 2x over 2. Factorising out 1 over 2 from the integrand here, the integral can be written as 1 over 2 times the integral from x equals 0 to x equals pi over 4 of 1 plus cos squared 2x dx. Let's call this equation number 1. Now the problem that we have here is integrating cos squared 2x. So we'll need to use a double angle identity to express cos squared 2x in terms of a double angle. Now recall that cos 2a is equal to 2 times cos squared a minus 1. And let a equal 2x. Hence, cos 4x is equal to 2 times cos squared 2x minus 1. We get that just by replacing the a with 2x, and 2 times 2x is 4x. Rearranging this identity to make cos squared 2x the subject, because we need to replace cos squared 2x in the integrand here, we get cos squared 2x is equal to half times cos 4x plus 1 over 2. So from equation number 1, we get I equals 1 over 2 times the integral from x equals 0 to x equals pi over 4 of 1 plus half cos 4x plus half dx. Collecting the like terms here and here, that equals half times the integral from x equals 0 to x equals pi over 4 of 3 over 2 plus 1 over 2 times cos 4x dx. And we can factorise out 1 over 2 from both terms in the integrand. So the integral is 1 over 4 times the integral from x equals 0 to x equals pi over 4 of 3 plus cos 4x dx. And that's certainly easier to integrate than an integrand involving cos squared 2x. So integrating 3 plus cos 4x, and taking into account the 1 over 4 here, we get 1 over 4 outside of 3x plus 1 over 4 times sine 4x from x equals 0 to x equals pi over 4. Applying the limits of integration, we get 1 over 4 times, now I'm going to open square bracket here, 3 pi over 4 plus 1 over 4 sine pi, and they're in round brackets, minus 0 plus 0. Now sine pi is equal to 0, so this term here is 0, we have a 0 here, 0 here. All we're left with is 3 pi over 4, and we're multiplying that by 1 over 4. So the integral evaluates to 3 pi over 16. Question 13, part C. The vector A is 1, 3, and the vector B is 2, negative 1. The projection of a vector x onto the vector A is k times vector A, where k is a real number. The projection of the vector x onto the vector B is p times vector B, where p is a real number. Find the vector x in terms of k and p. Define vector x with components u and v. Then the projection of vector x on vector A is given as k times vector A. Now that's given in the question. We'll call this equation number 1. But in terms of the dot product, that's equal to the dot product of vector A and vector x over the dot product of vector A to itself times vector A. We'll call this equation number 2. Now equating equations 1 and 2, We have k times vector A is equal to the dot product of vector A and vector x over the dot product of vector A to itself times vector A, dividing both sides of the equation by vector A to isolate k. We get k is equal to the dot product of vector A and vector x over the dot product of vector A to itself, where vector A is defined with components 1 and 3. Performing the dot products, we get k is equal to u plus 3v over 10, multiplying both sides of the equation by 10 to make 10k the subject. We get 10k is equal to u plus 3v. We'll call this equation number 3. Also, the projection of vector x on vector b is given as p times vector b. We'll call this equation number 4. And in terms of the dot product, the projection of vector x on vector b is equal to the dot product of vector b and vector x over the dot product of vector b to itself times vector b. We'll call this equation number 5. Equating equations 4 and 5, we have p times vector b is equal to the dot product of vector b and vector x over the dot product of vector b to itself times vector b. Dividing both sides of the equation by vector b to isolate p, we get p is equal to the dot product of vector b and vector x over the dot product of vector b to itself, where vector b is defined with components 2 and negative 1. Performing the dot products, we get p is equal to 2u minus v over 5, multiplying both sides of the equation by 5 to make 5p the subject, we get 5p is equal to 2u minus v. We'll call this equation number 6. The next step is to solve equations 3 and 6 simultaneously for u and v. The simultaneous equations are u plus 3v equals 10k and 2u minus v equals 5p. Previously they were equation numbers 3 and 6, but to make the referencing a little easier, I've relabeled those equations as equations 7 and 8. Using the elimination method, we can eliminate v to find u in terms of k and p, and we do that by taking equation number 8 and multiplying all terms by 3. So we form the following set of simultaneous equations. U plus 3v equals 10k, nothing changes there. We'll call that equation number 9, but then this equation here, equation 8, becomes 6u minus 3v equals 15p. We'll call this equation number 10. So if we take equation number 9 and add to it equation number 10, the terms involving 3v will cancel. So we get 7u is equal to 10k plus 15p. Dividing both sides of the equation by 7 to isolate u, we get u is equal to 1 over 7 times open bracket 10k plus 15p, close bracket. The next step is to eliminate u to find v in terms of k and p. And we can do that by taking equation number 7, multiplying all terms by 2. So we have a term involving 2u in both equations, and then we can eliminate u to find v in terms of k and p. And we form the following set of simultaneous equations. 2u plus 6v is equal to 20k, we'll call this equation 11, and 2u minus v equals 5p, we'll call this equation 12. So if we take equation 11 and subtract from that equation 12, we eliminate the terms involving 2u. So we have 7v is equal to 20k minus 5p. Dividing both sides of the equation by 7 to isolate v, we get v is equal to 1 over 7 times open bracket 20k minus 5p, close bracket. Now we can express vector x in terms of u and v. And that's equal to 1 over 7 times 10k plus 15p, which is our u component, and then 20k minus 5p, which is our v component. We can factorize out 5 from both the u and the v components, so vector x can be expressed as 5 over 7 times 2k plus 3p as our u component and 4k minus p as our v component. Question 13, Part D. Using the substitution u equals e to the power of x plus 2 times e to the power of negative x, and considering u squared, find the integral of e to the power of 3x minus 2 times e to the power of x over 4 plus 8 times e to the power of 2x plus e to the power of 4x dx. The substitution given is u equals e to the power of x plus 2 times e to the power of negative x. Differentiating u with respect to x, we get du dx is equal to e to the power of x minus 2 times e to the power of negative x. Expressing du in terms of dx by moving the differential dx over to the right-hand side by multiplication, we get du is equal to e to the power of x minus 2 times e to the power of negative x dx. We'll call this equation number 1. Later on, we'll need to replace an expression involving the differential dx with the differential du. Now the question also asks us to consider u squared. So squaring the substitution, we get u squared is equal to e to the power of x plus 2 times e to the power of negative x in brackets to the power of 2. Applying perfect square expansion, we get u squared is equal to e to the power of 2x plus 4 times e to the power of negative 2x, and we'll call this equation number 2. The next stage involves reworking the integrand into an appropriate form using algebra, and in particular to use equation number 1 to replace the dx, but also using equation number 2, which has something to do with the denominator. So what I'm going to do first is to express 8e to the power of 2x as a sum of two terms. So I'm going to break up 8e to the power of 2x into a sum of two terms, 4e to the power of 2x plus 4e to the power of 2x. So this 8e to the power of 2x term is the sum of this term here and this term here. The next step is to factorize out e to the power of 2x from the numerator and from the first three terms of the denominator. So I'm going to leave this last term here alone. And we get the integral of e to the power of 2x, open bracket, e to the power of x minus 2 times e to the power of negative x, close bracket, over e to the power of 2x, open bracket, 4e to the power of negative 2x plus 4 plus e to the power of 2x, close bracket, plus 4 times e to the power of 2x dx. Notice that the numerator and both terms of the denominator, so this term here and this term here, all involve a factor e to the power of 2x. So dividing the numerator and the denominator by e to the power of 2x, we get the integral of e to the power of x minus 2 times e to the power of negative x over 4e to the power of negative 2x plus 4 plus e to the power of 2x plus 4. Now if we go back to equation number 1, du is equal to e to the power of x minus 2e to the power of negative x dx. That replaces the numerator, including the differential dx. And for the denominator, what's in brackets here is replaced with u squared. Since u squared is equal to e to the power of 2x plus 4e to the power of negative 2x, so this whole bracket here can be replaced with u squared. So the whole integral can now be expressed in terms of u, and we get the integral of du over u squared plus 4. So performing the integration, that equals half times inverse tan of u over 2 plus the constant of integration c, but we want the solution to be in terms of x, and u is equal to e to the power of x plus 2 times e to the power of negative x. So the integral is equal to half times inverse tan of e to the power of x plus 2 times e to the power of negative x over 2 plus the constant of integration c. Question 14, Part A. Find the domain and range of the function that is the solution to the differential equation dy dx equals e to the power of x plus y and whose graph passes through the origin. The differential equation can be expressed as dy dx equals e to the power of x times e to the power of y. If we reverse this, if we're multiplying two terms with the same base, we add the indices. So e to the power of x times e to the power of y is e to the power of x plus y. So the reversal of this is this. Now applying separation of variables, we have dy over e to the power of y is equal to e to the power of x dx. Now dy over e to the power of y can be expressed using negative indices. So we have e to the power of negative y dy is equal to e to the power of x dx. Integrating both sides of this equation, we have the integral of e to the power of negative y dy is equal to the integral of e to the power of x dx. And performing the integration, taking note of the negative index here, we have negative e to the power of negative y on the left-hand side equals e to the power of x plus the constant of integration c, which we need to find. Now it's given that the graph, or the solution, passes through the origin. In other words, when x equals 0, y equals 0. So substituting x equals 0 and y equals 0, here and here, we have negative e to the power of negative 0 is equal to e to the power of 0 plus c. And negative e to the power of negative 0, of course, is negative 1, is equal to 1 plus c, which gives us a value of c of negative 2. Hence, the solution to the differential equation dy dx equals e to the power of x plus y is negative e to the power of negative y equals e to the power of x minus 2. But we want to make y the subject. Firstly, multiply both sides of the equation by negative 1 to eliminate this negative here. We have e to the power of negative y equals 2 minus e to the power of x. Taking the natural logarithm of both sides, we have ln of e to the power of negative y equals ln of 2 minus e to the power of x. And ln of e to the power of negative y is negative y, and that's equal to ln of 2 minus e to the power of x. And multiplying both sides of the equation by negative 1 to isolate y, we get y equals negative ln of 2 minus e to the power of x. Consider the domain of the function y equals negative ln of 2 minus e to the power of x. Now an ln function expects a value that's greater than 0. That means 2 minus e to the power of x has to be greater than 0. Rearranging this inequality to isolate e to the power of x, we get e to the power of x is less than 2, and taking the natural logarithm of both sides, we get x is less than ln of 2. Let's consider the range. And let's see what happens as x approaches negative infinity. Now, if we go back to our function here, e to the power of negative infinity will approaches 0, which means that y approaches negative ln of 2. And I've stated that here. As x approaches negative infinity, y approaches negative ln of 2 since e to the power of x approaches 0. Let's see what happens as x approaches ln of 2. If we go back to our function here, e to the power of x approaches 2, which means ln of 2 minus e to the power of x approaches negative infinity, but it's negative ln of 2 minus e to the power of x. This is a positive. And a negative over negative, of course, turns this negative infinity into a positive infinity. Hence, y approaches infinity, also given dy dx is greater than 0. That means the gradient of the tangent at any point is positive. That also means that the graph is monotonic increasing. So, if this is the low point of the graph, in other words, y approaches negative ln of 2 at its low point, from this point, the graph goes up to infinity. Again, because the gradient is positive all the way through. So putting that all together, the domain of the function is negative infinity comma ln of 2 in interval notation, noting the round brackets, so it doesn't include the endpoints. And the same thing goes for the range. We're using round brackets because the endpoints are not included. And the range is negative ln of 2 comma infinity. Question 14, Part B. For what values of the constant k would the function f of x equals kx over 1 plus x squared plus arctan of x have an inverse? For the function f of x to have an inverse, it must be either monotonic decreasing or monotonic increasing exclusively. In other words, one or the other, but not both. Now, f of x is defined as kx over 1 plus x squared plus arctan of x. Now, as a side note, arctan of x is equivalent to writing inverse tan of x. Now, we need to find the first derivative, f dash of x, so differentiating f of x with respect to x, applying the quotient rule to the fraction here. Since we have a function of x in the numerator and the denominator, and the derivative of arctan of x is simply 1 over 1 plus x squared, we get f dash of x is equal to k times 1 plus x squared in brackets minus kx times 2x in brackets over 1 plus x squared in brackets to the power of 2 plus 1 over 1 plus x squared. We can combine both fractions together if we can find a common denominator, and that's simple enough. If we look at the second fraction, we have a 1 plus x squared here. If we square that, we end up with a common denominator with the first fraction. And we can do that by multiplying the numerator and the denominator by 1 plus x squared. So f dash of x is equal to k times 1 plus x squared in brackets minus kx times 2x over 1 plus x squared in brackets to the power of 2 plus 1 plus x squared over 1 plus x squared in brackets to the power of 2. We now have a sum of two fractions with a common denominator. I'm going to combine the numerators together and expand the brackets at the same time. So we get f dash of x is equal to k plus kx squared minus 2kx squared plus 1 plus x squared over 1 plus x squared in brackets at the power of 2. Combining like terms, we have a kx squared minus 2kx squared there. So we get f dash of x is equal to k minus kx squared plus 1 plus x squared over 1 plus x squared in brackets to the power of 2. Factorising x squared from this term here and this term there, we get f dash of x is equal to k plus 1 in brackets plus x squared times 1 minus k in brackets over 1 plus x squared in brackets to the power of 2. We now have two cases to consider. In the first case, f dash of x greater than or equal to 0, and in the second case, f dash of x less than or equal to 0. Noting that the denominator of f dash of x, that is 1 plus x squared in brackets to the power of 2, is greater than 0 for all real x. So we only need to consider the value of the numerator. Let's consider case 1, f dash of x greater than or equal to 0. We want the numerator, k plus 1 plus x squared times 1 minus k in brackets to be greater than or equal to 0. Now, x squared is greater than or equal to 0 already, so we want k plus 1 to be greater than or equal to 0 and 1 minus k to be greater than or equal to 0. And I've noted that here, k plus 1 greater than or equal to 0 and 1 minus k greater than or equal to 0. This implies that k must be a value that's greater than or equal to -1 and less than or equal to 1 for both of these conditions to be true simultaneously. Let's consider case 2, f dash of x less than or equal to 0. In other words, the numerator k plus 1 plus x squared times 1 minus k in brackets less than or equal to 0. This implies that k plus 1 must be less than or equal to 0 and 1 minus k less than or equal to 0 simultaneously. This means k must be less than or equal to -1 and k must be greater than or equal to +1. And that's not possible. So there is no solution for case 2. So the only valid solution is case 1. Therefore, f of x has an inverse for values of k greater than or equal to -1 and less than or equal to 1. Question 14, Part C. Part 1. Explain why the equation inverse tan of 3x plus inverse tan of 10x equals theta, where theta is greater than negative pi and less than pi, has exactly one solution. The functions y equals inverse tan of 3x and y equals inverse tan of 10x are both monotonic increasing functions, and hence one-to-one. That means both functions pass the vertical and the horizontal line tests. Considering the derivative of inverse tan of kx for some value of k that's greater than 0, we get k over 1 plus kx in brackets to the power of 2. Now the derivative is positive for all real values of x. And that explains why inverse tan of 3x and inverse tan of 10x are monotonic increasing. Now the sum of two monotonic increasing functions is also monotonic increasing and one-to-one. Now given that inverse tan of kx for some positive value of k is greater than negative pi over 2 and less than pi over 2, also given the fact that it's monotonic increasing, then the sum of the two functions, inverse tan of 3x plus inverse tan of 10x, must be greater than negative pi and less than pi. And because this is monotonic increasing, the horizontal line y equals theta must intersect with the graph y equals inverse tan of 3x plus inverse tan of 10x exactly once, where theta is a value greater than negative pi and less than pi. Therefore, the equation inverse tan of 3x plus inverse tan of 10x equals theta has exactly one solution, where theta is a value greater than negative pi and less than pi. Part 2. Solve inverse tan of 3x plus inverse tan of 10x equals 3 pi over 4. Let A equal inverse tan of 3x and B equal inverse tan of 10x. Taking the tan of both sides of both equations to isolate the 3x and the 10x, we get 3x is equal to tan of A and 10x is equal to tan of B. And the equation inverse tan of 3x plus inverse tan of 10x equals 3 pi over 4 can be expressed in terms of A and B. Since inverse tan of 3x is A, inverse tan of 10x is B, so we can write the equation as A plus B equals 3 pi over 4. Taking the tan of both sides of that equation, we get tan of A plus B, so this is the sum of two angles, or the tangent of a compound angle, is equal to tan of 3 pi over 4. Now tan of 3 pi over 4 is an exact ratio, we get negative 1. And expanding tan of A plus B, we get tan A plus tan B over 1 minus tan A tan B. Now recall that tan A is equal to 3x and tan B is equal to 10x. So we can express the left-hand side of this equation in terms of x. So tan A is 3x, tan B is 10x. So the equation becomes 3x plus 10x over 1 minus 3x times 10x is equal to negative 1. Now 3x plus 10x is 13x. 1 minus 3x times 10x is 1 minus 30x squared, and that equals negative 1. And by cross multiplication, we form the equation 13x is equal to 30x squared minus 1. Rearranging this equation here to form a non-monic quadratic equation, we get 30x squared minus 13x minus 1 equals 0. So using the quadratic formula, we get x is equal to 13 plus or minus the square root of negative 13 in brackets squared minus 4 times 30 times negative 1 over 2 times 30. And we get these two solutions. We get x is equal to negative 1 over 15 and x equals 1 over 2. But if you recall from part 1, for any given value of theta, there is exactly one value of x that will map to that value of theta, since the function y equals inverse tan of 3x plus inverse tan of 10x is monotonic increasing and one-to-one. So out of these two solutions, only one of them will be valid and correct. So we need to test both of those solutions. Now when x is equal to 1 over 2 or half, inverse tan of 3 times 1 over 2 plus inverse tan of 10 times 1 over 2 equals 3 pi over 4. So that's correct. And when x is equal to negative 1 over 15, the value of inverse tan of 3 times negative 1 over 15 plus inverse tan of 10 times negative 1 over 15 is approximately negative 0.785, which is certainly not equal to 3 pi over 4. So this solution here is incorrect. Therefore, the only solution is x equals 1 over 2. Question 14, Part D. A particle is projected from the origin with initial speed v at an angle of theta to the horizontal. The position vector of the particle, vector r of t, where t is the time after projection and g is the acceleration due to gravity, is given by vector r of t equals vt cos theta for the horizontal component and vt sin theta minus gt squared over 2 for the vertical component. Do not prove this. Let d of t be the distance of the particle from the origin at time t, so d of t equals the magnitude of vector r of t. Show that for theta less than inverse sine of the square root of 8 over 9, the distance d of t is increasing for all t greater than 0. By Pythagoras' theorem, the square of the distance, so d squared, is given by the sum of the squares of the vertical and horizontal components of the vector r of t. So d squared is equal to vt cos theta in brackets squared, so that's the horizontal component squared, plus vt sin theta minus gt squared over 2 in brackets squared, so that's the vertical component squared. Applying perfect square expansion to both of the terms in brackets there, we get d squared is equal to v squared t squared cos squared theta plus v squared t squared sin squared theta minus 2 times vt sin theta times gt squared over 2 plus gt squared over 2 in brackets to the power of 2. Factorising out v squared t squared from this term and expanding the brackets here and here, we get d squared is equal to v squared t squared times open bracket cos squared theta plus sin squared theta close bracket minus vgt cubed sin theta plus g squared t to the power of 4 over 4. Now cos squared theta plus sin squared theta is the Pythagorean trigonometric identity equal to 1. So d squared simplifies to v squared t squared minus vgt cubed sin theta plus g squared t to the power of 4 over 4. Now d represents a distance, which means it can't be negative. And since the distance d is greater than or equal to 0, if d squared, in other words, this expression here, is monotonic increasing, then d itself is also monotonic increasing. So what we can do is to show that the derivative with respect to t of d squared is greater than 0. And if that's the case, then d itself, the rate of change of the distance with respect to time, is also going to be greater than 0 for all t greater than 0. So differentiating d squared, so that's this expression here, with respect to t, we get 2v squared t minus 3vgt squared sin theta plus g squared t to the power of 3. And we can factorise out t from all three terms, and that gives us t times open bracket 2v squared minus 3vgt sin theta plus g squared t squared close bracket. Notice what we have in the brackets. We have a quadratic expression in the variable t, and if we read it backwards, it would be g squared t squared minus 3vgt sin theta plus 2v squared. This would be the constant term of this quadratic expression. And this term here would be the middle term. Now we know that t itself is greater than 0. So what we need to show is that the quadratic expression here is positive for all values of t. And the only way that that's possible is if the discriminant of this quadratic expression is negative. If we were to graph this quadratic expression, it would be a concave up parabola, but we want the parabola to be totally above the x-axis or the horizontal axis. And that happens when the discriminant delta is negative. So d dt of d squared is greater than 0 if the discriminant delta of g squared t squared minus 3vg sine theta in brackets times t plus 2v squared is negative for all values of t greater than 0. So we want to solve the inequality delta less than 0. Now delta is b squared minus 4ac. So that's the component that's inside the surd of the quadratic formula. And using this quadratic expression here, this is our b squared. So 9v squared g squared sine squared theta minus 4ac. So minus 4 times g squared times 2v squared less than 0. So multiplying these terms here together, we get the inequality 9v squared g squared sine squared theta minus 8v squared g squared less than 0. Now we can divide all terms by v squared g squared since v squared g squared does not equal 0. So we won't have a division by 0 error. So the inequality simplifies to 9 squared theta minus 8 less than 0. And rearranging the inequality to isolate sine squared theta, we get sine squared theta less than 8 over 9. Now, since the angle of projection theta is greater than or equal to 0 and less than or equal to pi over 2, that means the value of sine theta itself is positive. So taking the square root of both sides of this inequality, we get sine theta is less than the square root of 8 over 9. And taking the inverse sine of both sides, we get theta is less than inverse sine of the square root of 8 over 9. Therefore, d of t is increasing for t greater than 0, given that theta is a value less than inverse sine of the square root of 8 over 9.